Groove Salad, one of several cool programs from Soma FM.
We gaan beginnen. Everyone, we're going to get started. If you're ready, take your drinks and see you over there. Do we have a hashtag? I don't know. Yeah, GraphTB, Near4j, GraphTB or Near4j. Yep. All right. Very good. You're all very silent all of a sudden. Cool. I just want to make sure that we get started. I've just ordered the pizzas, so they will be here around 8 o'clock, and then we'll have a little break and have some food, and then continue for another couple of presentations. But first of all, welcome everyone, and thank you for coming. It's great to see a good group of people at our GraphTB meetup in Brussels. We haven't done a meetup in like 3 or 4 months, I think. The last one we did was I want to say October time frame last year, and today we're going to do this as a part of a European tour that Near4j has started. I don't know if you guys have ever heard of Graph Connect, which is like a conference that Near4j has been organizing for a couple of years. We also always used to attract like a bunch of, like 1,000 people in London, and a couple of hundred more in New York or in San Francisco. But we decided that we want to take this closer to the European cities, and we organized some events across Europe. And on the back of those events, we've organized this meetup, and I want to thank all of the speakers for helping us out. And as you can tell, it's mostly about case studies tonight. You'll hear a lot about people using GraphDBs and how they are using it specifically. So we'll have Dirk Vermeulen, who is going to present on data modeling. You're over there, yep. Then we'll have Ignas from Vector Consulting around how to map IT landscapes. We'll do some pizza. And then Surya is going to talk to us on a use case around protein association networks. And Tom, you're going to send us home with more stories around how you build platforms on GraphDBs, right? Yeah, so this GraphTour thing, it's been quite amazing. We thought it was going to be so much easier than doing this big conference, but then snow happened, Uh, we had actually we did 8 different locations across Europe, and on one of the locations, which I'll show you, so we reached about 2,500 people, went all across Europe, but in London we had like 2.5 millimeters of snow, and that completely paralyzed everything. You know, so it was like we had like 800 registrations and 250 people show up because of 2.5 millimeters of snow. I woke up that morning in a hotel in London, and the BBC was saying, "Do not go out. You know, you will die on the road." Not really. Um, and we went to Stockholm where they had like 2 meters of snow, and we're like, so what's happening? So we did 8 locations. We have one more location left, which is Milan next week. And the most amazing part of that graph tour, and you know, it's also kind of the reason why we decided to talk about use cases today, is that we had so many great case studies. It was crazy. You know, you see some of the logos here, and I don't know if you're, some of them are probably familiar with you, but these are like really, really, you know, big clients, big customers, big users of Neo4j. They're not all customers. Some of them are just community users, but damn it, those are big names, right? And so that kind of tells you that it's growing up a little bit. You know, the next generation of Volvo cars is being built with a GraphDB. That's why I drive a Volvo, actually. You know, these guys, Previa, they were talking about social network analysis for mental health treatments in Sweden. It's a commercial company, but they offer this as a service actually to try and help people better. Belgian company called Neanex from Berchem near Antwerp, doing really fancy stuff on building information management. Right, so managing buildings as a network, right? You have a building which has floors and it has rooms, and in the room you have projector, and you know you have all these relationships between the different items. A very fancy use. Oh, that's the wrong direction. Neanex, really cool use case. Albelli, you may have used this for your Christmas cards or your kids' photo albums. They use Neo4j for recommendations, you know, for recommending what next to print, what photos next to print. Unbelievably big use case. They have 2.3 petabytes worth of photos, and not all in the GraphDB, luckily, but all the metadata is actually in the GraphDB. Fantastic use case. By the way, you'll get these slides, and you will see the links at the top of the site, so you can watch them yourself if you feel like it. ING in Luxembourg doing regulatory reporting, which is quite stringent in Luxembourg, as you may imagine. Workday, ERP software vendor. I mean, I'm just talking about the cases that were presented at the GraphTour, right? There's so many other cases out there that are being presented. This is one of my favorites, you know, recipes. Recipes as a graph. It's actually, I've written about this on my blog a couple of times, and it's really, really a great use case. So these are just some of the use cases that you see out there. Chatbots, all of that stuff. So many cool things are happening. Now, what does that mean? And I was just going to talk for 15 minutes about, you know, the state of the graph. Well, it means that this thing is growing up, right? We used to do meetups, and Ines, I don't know if you were there or Tom, we used to do meetups with like 3 people. And that's no longer the case. You know, there's a lot more people. We reached 2,500 people on the GraphTour, but we also got like a little bit of press exposure, right? With Panama Papers or Paradise Papers or Russian trolls, you know. All of these things are coming to surface. Why? Because of GraphDBs. Right? People are looking at this stuff, investigating, or finding new patterns because of GraphDBs. You know, one of my favorite cases is this thing. Have you ever heard of PageRank? PageRank is a graph algorithm that Google uses. And, you know, as you can tell, and I see a couple more people here with the same amount of gray hair as me, you know, web search before Google, it really sucked, right? It was really bad. But Google actually changed the game by implementing something called PageRank, which allowed them to rank results much better, not based on keywords, but based on the number of connections between pages. Right? That's how Google works. It's a lot more sophisticated nowadays, but they rank results based on the number of connections between the pages. If you could apply that to a cancer tumor, right? A cancer tumor has connections between tumor cells, right? What if you could say this tumor cell is more important than that tumor cell, right? This is actually what people are doing, what treatments people are now developing to actually target the cancer treatments at the cells that need to be targeted. And those are the ones that have a lot more connections, because the ones that have a lot more connections cause the metastasis, right? The spreading of the cancer, right? I mean, I'm just trying to illustrate how important this is becoming, right? This is a picture of one of our customers that you may have heard of, called NASA. NASA is developing a knowledge base for lessons learned. You know, what have we learned in 50 years of space exploration, right? And one of the things that they actually, what you see here is a landing capsule, right? It's a landing capsule when the astronauts come back from space. In Project Orion, which is the project that NASA is running today to get us to Mars, to get humans to Mars, one of the biggest issues that they have is that the landing capsule keeps topping over. So yes, we will send them to Mars. Yes, we will get them back. But when they land in the ocean, they're fucked, right? And so they didn't know how to do that. And they actually went back and talked to astronauts that were in Apollo 13 to try and understand, you know, how did you guys do that? And they found out these stories, you know, and a knowledge base that allowed them to save a lot of time and develop this landing capsule in a more efficient way. So this is really taking off. There's a lot of people using graphs. Back in 2014, back in 2014, I need to use my fancy clicker, sorry. In 2014, Forrester thought 25% of people of the enterprises will be using graph databases, and we've just seen in 2017 that's more than 50% already. So this stuff is not imaginary. It's really taking off. The best is yet to come. And so what's happening? There's a lot of stuff, a lot of investment happening in Neo4j as a database. I don't want to go into that in too much detail, but I guess we're really trying to invest into this graph-specific workloads, right? Where we really specialize in getting real-time results, both at real-time, read time, and at write time, thanks to this concept called index-free adjacency, right? We were looking for the most expensive sounding word, right, to describe this characteristic. In humans' terms, it means everything knows about its neighbor, right? So if you look something up in a Neo4j database, it will automatically know what it's connected to, right? It doesn't need to go back to the index to find the adjacent thing, right? The next thing, the neighboring thing, right? Sounds expensive, right? Index-free adjacency is kind of like the secret sauce of Neo4j, right? Because it allows us to do these traversals across the network super fast. Once you find something in Neo4j, it just pointer chasing, right? That's kind of like the secret sauce. And it really allows you to do these graph operations much more quickly. Don't take my word for it. Take a look at it yourself. You will literally see things that used to take minutes or hours, and all of a sudden they will take milliseconds. At the same time, It is a ACID database, and we continue to invest into this ACID property of graphs. Why? Because it's super easy to fuck up a graph, right? If you do something wrong with a graph, you not only write the wrong data, but you could end up disconnecting parts of the entire data set, right? So, which is why we really feel like this eventually consistent data model that lots of people are implementing in the big data space, it's not a good fit for graphs. Graphs need to be consistent all the time. Otherwise, you're at risk of spreading corruption. One of the other things that Neo4j has been known for and that we continue to invest in is Cypher. You may have heard of Cypher. It's not just a character in the Matrix movie. It's also a query language, a declarative query language. Right? We're trying to copy the textbook of relational databases. Right? Relational databases conquered the world because of SQL. Right? Because SQL was so easy to use compared to a COBOL copybook. Right? We're trying to kind of copy that and basically say, if graphs are going to be successful, we'll need a declarative query language, and that's hopefully going to be Cypher. And it's such a joy to use. If you haven't used it yet, try to do this SQL statement over here, right? And replace it with that Cypher statement over there. It's so much easier to read. It's so much nicer to do these graph operations. Continue to invest in that, and now the current release of Neo4j is 3.3, where you will see a lot of emphasis on performance, on security, on developer productivity, lots of different aspects to this, but I'll leave it to you to kind of dig into that. Want to wrap up by saying, there's a lot more than just the Neo4j database. At least from our perspective, we really think that yes, the database is super valuable and super interesting, but every time again we hear customers say, if I actually want to use the database, I need more than that. I need more than just the database. And so we've started dubbing this the graph platform vision, where we've started to develop a number of tools around Neo4j that make things a lot more easier for you. Like for example, a very easy way to integrate with more traditional big data environments. Right? So if you're using Hadoop or if you're using Spark, right, there's some really interesting work happening to very, very easily import data from Hadoop, from Spark, do some processing on it and send it back, or vice versa. Right? So where you can basically have the right tool for the job at every step of the way. Right? For the really big data number crunching petabyte style operations, you'll have Spark or you'll have Hadoop. But if you want to do a graph traversal across an unknown number of hops between two different entities that you don't necessarily know yet, you probably want to use Neo4j. Right? Some really cool stuff happening on algorithms, on graph algorithms. I mentioned PageRank before when we were talking about the cancer research, but there are so many of those graph algorithms out there that people just seem to have forgotten about. Everyone had to learn about them in their math classes, but they thought it was complicated and forgot about it. And there are some really important graph algorithms out there that can really solve problems that are very difficult to solve in a different way. Like for example, centrality, right? Centrality, where we're trying to understand which parts of the graph are more important than others, right? More central than others, and there's different measures, different scores that you can apply to that. Community detection, right? Actually, Belgium has a very important history here, because we have actually developed, or the Louvain University has actually developed some of the leading community detection algorithms that allow you to find clusters in networks, right? That allow you to find communities in networks. And then, of course, last but not least, pathfinding, where we try to understand the links, the indirect links between two things, right? Without having to hypothesize. I was talking to someone here about it earlier. The big difference between pathfinding on an Neo4j database and another data platform is that you do not have to hypothesize, right? If I want to understand the link between Mossack Fonseca in the Panama Papers and Putin, I don't have to hypothesize. I don't have to say, I think the link is like this. I can just say, got Putin, got Mossack Fonseca, show me how they're linked. Right, which is a very different question, I'm hoping you understand. Right, so pathfinding is a very important graph algorithm, and actually Neo4j turns out to be surprisingly good at it. Some people may know of GraphX, which is a graph algorithm package running on top of Spark. Neo4j is actually quite good at this. A lot of work going on in the visualization space. Right, if you want to sell a GraphDB to your boss, most likely he's going to ask you for some dancing bubbles, and you know, there's a lot of work going into that, and we are actually going to come out with some new products around that, but there's some fantastic products already out there, and the Neo4j browser doesn't do a shitty job either. So that's my state of the graph kind of layout. If you want to have more information a little bit later on, then please feel free to grab me or my colleague Case or even Matt. There's a couple of us from Neo4j here that can have a chat with you about a little bit more detail. But now I think I'd like to hand it over to Dirk. Is that okay for a first presentation on how he uses it for data modeling? Is that okay? Unless you guys want to stop me? Yep. All right. Let's do that.
And this page up and page down? Okay. Why am I? High tech, really high tech. Sorry, it's a little bit more a vintage presentation because I think you had a very nice presentation. What I want to tell about is a little bit the modeling with Neo4j. I'm using it on a daily basis for small applications, but I really use it, and that's what I want to show. It used to be CMDB modeling, but I dropped the CMDB because there's another example as well on it. A very short introduction. I started at EDS back in '86 in the car manufacturing plant in Opel Antwerp, which was a very nice job, but not related to that. Moved on to Opel dealer business and then started with application monitoring. Application monitoring means you need to monitor if an application is up and running. If not, you want to understand what component is failing, and that's when you start looking into the configuration of your applications, when you start working with configuration management databases, and where I got a link to CMDB as well. Later on, I had some open data projects at Flemish government, which were really interesting. I was a bit lucky to be winner of Neo4j GraphGIS Challenge a couple of years ago, and those last two things allowed me to move into the analytics and data management team, away from infrastructure team, which is a little bit more promising for the future, I think. Companies changed. ADS was acquired by HP, HPE. Now we are DXC technology, merged with CSC. So a bit interesting there as well. The goal of the presentation, what I want to explain is I'm using it daily for configuration management database, for a hobby project as well, the GraphGIS thing, where you can use whiteboards for validation. I'm using it, I see I'm using modeling with double L, Rick was using with single L, not sure what to use. I'm using it really as an excellent overview to look into problems and to tackle problems in another way. and it became the first view. SQL, Excel, VLOOKUP is traditionally a first view to look at problems. Neo4j proves to be very, very good, mainly due to the visualization. Visualization is really good for that. And for that, I need to be able to import, convert my data into Neo4j very fast, and that's what I hope I'll be able to show. I use Python and the Py2Neo library for that. Py2Neo and Python is very good for it. Visualization asset, that's really very important. Very short, what is a configuration management database for people here who are into data analytics and biotechnology and all things? From an infrastructure point of view, you want to understand how my data center looks like. You have your infrastructure, server, network, everything. You have your software installed on servers, and with software, you configure software, combine it into applications. That's all what you want to know. You want to know the relation between all of them. Why? For service management. If an application doesn't work, you want to know where you want to look at. Is it my database? Is it a network? Can be everything. But you better know where to look at and where not to look at. Impact analysis, if I switch off a computer, what applications will be impacted? That kind of question. So that's why in infrastructure world you want to use configuration management databases. Challenges with the configuration management databases, like I'm in the service management industry. Every customer has a configuration management database, but every customer has its own implementation of a CMDB. So you're like different models with all customers you're arriving at. From specific tools, homegrown implementations, and any kind of combinations. There's a variable quality. What I want to say is quality is very good always, but the focus is different. Sometimes focus is on infrastructure in engineering type companies. Sometimes it's really on the application to software relation in more process related industries, like thermal government is very good at that. And there's a variable level of data collection as well. Sometimes you have a lot of information in CMDB, in the configuration management database, and then specific teams, like the database team, they have their own set of information that doesn't fit into the model. But you want to use it because it's very interesting information. You want to use it. So if you want to work with different types of configuration management database, you need to understand what model has been implemented and what can I do with the other information that does not fit into the model, or how can I use it? A theoretical solution, DMTF, where a model is explained, but not important here. A practical solution, in fact, what I did was, and what you can do for many databases, you have all components, 2 tables, 1 table with all the components, 1 table with all the relations. In the components, you need to understand your component type. Is it software? Is it a server? Is it a network box? And then on the component table, you just have the consolidation of all your attributes. Add them and use them if it fits for the component type. Don't use them otherwise. Relations is then just component 1, the unique ID from the component 2, and the relation type. Try to limit your relation types as good as possible. In some cases, we just had 2 relations type, and is using, which is a weak relation, and dependent on, which is a very strong relation. You're looking for the strong relation. So, in fact, 2 tables, components, relations, it goes to a graph model already very closely. The component relation model helps. You need customized scripts to check if your data is valid, if it can be, if it's correct, if it's valid. You can add data that doesn't fit any other model, so that's good. The result is that the complexity is moved away from your database model, it's moved into your scripts instead, so it's not gone. And that is where Neo4j does a lot of help with a component relation table. Your component can easily be translated into a node. Component type is then the node label. I have a server, I have a software instance, I have an application. And all non-empty attributes, I have the whole list of attributes, every possible attribute is part of my table. So just add non-empty attributes as node properties for this specific node. That's your node in the Neo4j model then. And relation table are your relations with the relation type, is the relation type from the table as it was before. The customized scripts where the complexity was become now the cipher queries, which is, thanks to the visualization, a lot easier to use. It's called ASCII art based on visible model, and it looks like a little bit art as well to me. Result, you have a very good visualization, which should be possible here. Okay, what you see, oops, it's not very readable, I think, but what you see here is the schema of a database that was just loaded. You do not need to define your schema. Your schema is read from the database, so there's no need to define it. Of course, you need to be a little bit careful on what data to load and what relations you all put in to make sure that you have a schema that looks usable as well. URL on top, YWorks, that's a company that's doing a lot of visualization. They have a Neo4j Explorer interface that's free. It's not, no installation is required. The only thing you need to do is explain to YWorks where your Neo4j database is, and you have this visualization for free. So if you need to convince someone, that is really what helps me and why I'm using it on a daily basis as well. Previous slide was the schema. This is an extract of the data where you can see in orange the servers, my software instances, my solutions, my applications, and then my application instance. An application instance is a production instance of an application or a test instance or the quality assurance instance of your application. And you immediately see how my Oracle server is connected to 2 or 3 applications. I should check it. So it's a configuration that you or a schema you can use to discuss with clients, with your manager, with everyone very easily. You cannot do the same with an Excel sheet. I mean, that's a little bit more attractive, at least for me, and a little bit the reason why I'm using it on a daily basis as well. An example in the previous schema, a question that we have is what applications, for example, depend on a shared Oracle version, specific version. So what you do, start from the database schema, and then, as Rick has shown before, there's no need for a complex query. You just see, I have my, it's really hard to read, my software name here connected to a software version. So I need to have Oracle database version 11.2 in this case. My instance that is installed on the server, and for that I need to understand which instances are connected to more than one application, which server has instances that are connected to different applications, because that's where you have the problems to migrate your application. And the query is really, you just follow the arrows and write down everything you see. So there's not a lot of, how was this model built again in the past? You can easily see it, build a query. It's not a lot of typing. Neo4j console will do that for you. So you just type one word, one character, 2 characters, the rest is there automatically. So that's easy. So you can very easily go from your schema to your query, have the result, and the result here is at, wacht, was that here? Oops. Oh. Can I go, which button did I need? Yeah. The result, I won't show it. On top line, you see on the left orange, you remember a server. On the blue one, an application. So you see 2 straight lines, which means I can upgrade those oracles, no problem at all. No, I only need to talk to one application owner. On this server, I have a lot of application owners I need to talk to, a lot of coordination I need to do. And this application here is connected on 2 servers. So I need to make sure for this application that my 2 servers are upgraded at the same time. So I see where the complexity in the upgrade process is. And I can discuss it. So it helps me to progress with this. very briefly the data to import. I mean, if you, what I want to show here, you want to import data. I want to use it on a daily basis, so I need to be able to import my data, go very fast from an Excel into Neo4j. Excel looks like on the top row you have your columns and then all the data where you have technical data that's not important, and your attributes that are have some data or have not data, and IDs that are important, of course. Sorry for that, it's a little bit of Python scripting. Python is a very easy way to use it, and you can better invest. I mean, if you need to start with Neo4j, invest a little bit in Python, it will pay back very fast. What you need to do, find the file. Use the pandas library is one way to do it. It converts into a data frame, and then you just iterate over your data frame, convert your row into a dictionary, which means that the keys will be the column names, and the values are available or are not available. First you check then, here, is my key in the not in the ignore fields? So I'm not interested in technical data from other databases. I want to have real data. If it's not in a predefined list that I have defined, Pandas has a function to see that my value then is not null. And then if that means I have some information that I want to continue to use, and I add that as a parameter, and off you go. Then, the only thing you need to do is create a node, create a relation, and create the two relations, and off you go. So that's really the whole script. So just make these scripts in a sequence, and you can convert your Excels into Neo4j very fast and have the visualization you want. The second example, first one was components and relation table. The second example is use a whiteboard model. Really start from scratch. Whiteboard modeling is very good. Type of pictures you create during Skype meetings where you say some better things to do. Then you create that type of pictures. The problem here, that was his challenge as well. The problem is simple. I wanted to have some simple issues as well for my own to learn Neo4j. I mean, if you start with like 50,000 nodes and relations and you do a query, you don't know if the result is correct or not. So I want to have like 15 nodes and 17 relations and something to compare with. The problem, or the challenge I wanted to have was like if you go running, you have organizations, Kapitelloop, Bolletjesloop. You have a couple of races, 10 miles, 8K, 5K, and then we're part of a club and we say, we run as fast as possible. First one gets 50 points, second one 50, 45, 40, and so on for the main race. And then you do not want to do the main race, you do one of the side races. Then you just get the last one, -1, and that's a point for everyone then for the remainders. That's the model we want to use in an Excel, so I can compare. And the model itself looks like you have an organization, location, and a date, which city, which date. You have your main race and side races. And then on top, also good readable, you have the persons. And a person can be a finisher in a race. And what is, the only thing here is that you need to have a finish. Is it? Oops. A finisher need to be after another finisher. That's in fact the only thing you need to know. Not the exact location, the exact place in the race, but who's after who. That gives that allows to give the points for the race. What I did there was use the GraphGist. Portalgraphgist.org is the URL. That's from Neo4j, and that really allows to validate your model. You can compare it a little bit with Jupyter Notebooks. You write documentation, you write text, you write documentation, you write queries, you have your data. You can work with the data and add comments on it. So it allows to build the model. It allows to validate use cases. Can I get the finishers for the race? Can I get the finishers in exact sequence and only a list of finishers? So it really allows to build up your model. As a result, if you use the GraphGist in a good way, you have validated your model, your queries, your use cases are available. And next step then is you want to build a website, so you only need to focus on the Python scripting for the website, no longer on the queries, because you have them available. And you know that the query is working. The queries are there and are working. So GraphGIST is really helpful for new applications that you want to develop. An extract, a GraphGIST document, it's a doc, it is called, but it's like, how it's called, Markdown, comparable with HTML, but even simpler, even easier. So you have like first level, use the data, 2 equal signs before means it's level 2, 3 equal signs, get the finishers, it's level 3, that's the formatting you use. Then you have a little bit of text, shows as text there. Then you say, I cannot really read it, source cipher, and you do your cipher query to check the cipher query which comes here, which is querying the database that has been defined in query 1 then. Couldn't show that. It queries that, and then you say, I want to see the graph result, which is the picture there, and I want to see the table as well, which is the table below. And then you can see, is that what I wanted? Is that what I expected to have? And you continue working. That's not what in this case, it was not what I wanted. I wanted to have all finishers in a table as one row, but you have here 3 finishers in this sequence, which I had the 3 finishers in sequence, but I also had the 2 pairs, which is not really what I wanted, so I needed to add one more name, an unwind parameter in the query. There's a lot of help as well on Google. You find it without any problem. It is a hobby project. It means I work on it for like a couple of weeks, then it's there for months with nothing happening, and then you restart again, and then you say, what was the model again? The visualization helps to get on speed, to get on track again very fast. If you compare with Python SQL Alchemy, which is very good as well, we should do a meetup on that as well probably, but it's a lot more difficult to see the SQL Alchemy model, your model description. It's you need to think a little bit on it before you're on speed with it, while the Neo4j model is visual and it really helps to get on speed. So that's, for me, the main advantage to use Neo4j, and this YWorks Neo4j interface that was shown before, and which is available on top of it. So that's very good. So the website is available. I'm like happy with it, and it's built on Python with the Py2Neo. Py2Neo is a great library for it. It has been stable for a long period, but I've seen that it's and there's a new release now, so I need to look into the new features. So it's good it's still under development. Flask is a very good web framework if you're looking for something. Main reason I use that is that there's a very good tutorial on this URL. I think the slides will be distributed, so yeah, you will see. There's a very good tutorial on this URL on building websites with Neo4j and Flask. So that's a bit how I get started with Python, Py2Neo, and why I'm using it like daily, also in the weekends. So that's a bit of presentation. Any more questions or something? Or thank you.
Thank you, Dirk.
So
So we'll have a lot more questions later on. We're going to switch over to Ignas now because I know that the meetings are not going to be too long. So thanks a lot, Dirk. And now switch over to you, Ignas. I've got you. Yeah, we can use this. Yeah. And then the power is yours anyway. And I'm gonna add this.
So, okay. sliding a little bit. Okay, that's better. Okay, all right. I'm going to talk a little bit about how you can map the IT landscape as a knowledge graph. My name is Ignas. I work for Vector Consulting, a consulting company in Belgium, and we do a lot of graph work. I think we've been here since the beginning of the meetups from Neo4j. I don't have the fancy pointer, but I know what to get for my birthday this year. Let me explain you a little bit our business, consultancy business, of course. So we have a lot of consultants, and we have a lot of companies that are potential customers of ours, and we hope that we get a lot of customers, of course. And our issue is always to get the right consultant to the right customer. And in order to do that, we have a manual process usually. The companies, the customers, they ask for consultants with specific skills. So the customers, they will send out a notice, usually an email. Please, can you help us? We are looking for consultants with skill A, B, and C. We, of course, we have consultants who work for us, and we can deliver as a company the consultancy and the knowledge to the customer. That's basically our business. Oops. Very simple business in principle. But if the companies ask us some information about the skills they need, they are also giving us a little bit information about themselves. Because we know that if they ask for skill A and B, then that company probably is doing something with A and B. And so it's not only matching the right consultant to the right job. No, I can do without the clicker, but it's just that I have to be near here all the time. So probably a few people over there can't see me then, but that's okay. It's for the camera. Well, whatever. If you can install it. Okay, but now I'm too far, so here okay, so our consultants, they of course they have skills, and their skills they are presented in their CVs, maybe also in social media or other channels like the meetups that we have today. Basically, if we know that all of you are coming to this meetup, we all know that you have an interest in Neo4j, so you have actually given us a little bit of your information that we can use. And that's not just for this meetup, but for all meetups, and then on Twitter we know what people are tweeting about, on the Git what people are working on, and all these kind of things are a little bit of information about the skills the consultants have. And then we have the companies looking for those skills. So skills are central in our business. One thing we need to do is to match, based on the skills, the right consultant to the right customer. But at the same time, we can start knowing more about the companies. So we can map basically the IT landscape in the country if we get more and more information. We can also watch trends, skill trends, which is important because new technologies arise and old technologies will diminish, and we can actually see that, or try to see that in the data, and anticipate on that, because the consultants, they will always need to learn the newest things, and we need to know what is this new technology and how are we going to invest in that. So the way we started this is to build a graph model. It's a fairly simple model that I show here. There are some other nodes in the graph, but they are less important for the story. So central to everything is the skill. And we have, to the left is our company, and we are interested in a number of skills. So our company focuses on data and artificial intelligence, machine learning, some IoT sensor data. So that's the type of skills that we are really interested in. We are not so interested in Java developers or user interface development. So we have a number of skills that we are interested in. We have the consultants that work for us. They can be employees, they can be freelancers, doesn't really matter. We all consider them consultants. And they know particular skills. And on the other end, we have the customers, and they will send out job openings. And they offer openings for a specific job which needs some skills. So that's a very simple model. And we have automated this process. So when a customer submits a job opening, that's very often through an email, but it can also be a Word document. It can be from a website, a web page, you name it. It can be a lot of different things. They request specific skills. We scan all this. We scan it as it comes in, and we check if we can find any of the skills that we are interested in. And if so, we put that in the model, and it's a graph model, of course. We can also score consultants against each opening, because if a consultant has skill A and B but not C, then he probably scores less than one consultant who has a skill A, B, and C, which are all requested by the customer. So we can do an automatic scoring of the matching for consultants as well. What we then do is, if the scoring is above a certain threshold, then it's very interesting for us, and we need to take action, and we notify this, and we do this very simple through a Slack channel, and then it says ping, and we know something important we have to respond to. Also, of course, if consultants acquire new skills, we have to update the model. If we have a new consultant, we also have to add him to the model. That's 2 slides at the same time. So this is an example. In this case, I have censored some names, as you can see, but the rest, it's a real case. So the video AB is looking for some people, and in this case, they are looking for data science, deep learning, machine learning, and use cases. These are the kind of skills that we have found in this job opening. We have automatically ranked the consultants who match these requirements. They have a score of 66% in this case. We use color codings. The green ones, they are the ones that we really like, the skills that we are interested in. Other skills are in purple. That's because it's not just our company who can use this, but a different company which is interested in maybe different skills can use the same, exactly the same model, but the color coding will be different because the other skills will be highlighted. All right, I think that's the one where the skills were found. Actually, this is a typical job offer. There's a lot of blah blah and text, and not really a very detailed case where they talk about the real stuff, which is down here. And if you have to read all these incoming emails, it takes a lot of time, and there is quite a number of them coming in per day. So our algorithm allows it to do this all automatically and to respond within a minute. And we also know which emails are not important, so we don't have to read them, and others are important. So I talked about trends, for example. In this case, we see on the top, it's a time series. Every dot is 1 week of data. And we show here how often this company asks for any kind of job. Relevant or not, that's not in there. It's just how often, how active is this company. Down below we have bullets showing the scoring of the skills that this company has over all the requests that they have done there. It's the same as the table on the right, but just a different visualization. Again, the same color coding, so the green ones are the ones that we really like, and this company is doing a lot of other things that we don't like. So this is an example of a skill. We can do exactly the same kind of analysis on skills, where we see how often particular skills are asked for in time. This is 2 years of data, and you can see that there is a slight trend, a rising trend for business intelligence. So that's becoming a little bit more important over time. We also have companies that we find, the customers, the top companies asking for this particular skill. We also rank them. Unknown is the companies that we don't really know. A lot of requests that we get we don't know the company. It's kept secret until you really respond to it. So that's what is under unknown. I have to point. That's it. Okay, and then it goes twice. I think there is a delay. That's it. Well, it doesn't want to show that one, but it's not important. That's just one particular skill that we can also zoom in and see the importance of that skill over customers. Now, the reason why we can build all these kind of views easily is because everything is modeled as a graph. So we have a Neo4j underneath. This is our company in blue, and in green, it's all the skills that we really like. So that's what we scan all incoming requests for. We also have synonyms and so on for skills, so we have a clever matching. It's not just a grep. So here we find the times in the past 2 years that Neo4j was actually asked for as a skill, which is 4 times. We have 4 job openings from unknown companies in this case that required Neo4j skills. And we of course are very interested in that. But it's not a lot. So let me show you a different example. Here we have an example of IoT, which is quite a general term. So that's we see that quite a lot, and you can see that we are of course interested in that. But there are a lot of job openings, and all these openings they are linked to companies who actually request these skills. So we have Elia, Telenet, Digipolis. One is censored over there, and then the unknown. This is how the underlying graph is built, and this is the Cypher queries that we use to actually build the visualizations, and that we can navigate through the graph. So we can. That's it. Backwards is easier. If we focus on one company, for example, in the graph, like Digipolis, we see that it sends out a lot of job requests and with a lot of different skills. So this shows you how the internal of the graph really looks like. And I hear the pizzas coming probably. So I'm going to the last slide then. That's the key takeaways. Our business case is basically finding the right consultant for the right customer. We can do that in an automatic way now. Within a minute, we can respond. Graphs are actually excellent to model the insights of our business, and I think of many businesses. We use an ontology for our business, which is our skills. Our skills are central, and we need to define our skills as an ontology. We connect the ontology to all the dynamic business entities that we have defined in the model, and we connect it as a graph. And from then on, we can do real-time matching mapping the landscape, who is doing what kind of IT, and trending as well, finding trends in IT. And we actually use that on a daily basis. And it has helped us a few times already. I think that's the end of my story, and hopefully you have learned something.
So I think we have time for a couple of questions, maybe, because Domino says that the pizzas are already here, but we can't find them.
Ah.
They're supposed to be on their way. They'll be there in any minute now. But if you have any questions, either for me or for Injas or for Dirk, then no.
I see a question there. Well, we don't really have issues of privacy because these are things that really are sent to us, and we are supposed to respond to this. So we are allowed to read these emails and texts. So whether we do that with our eyes or whether we do that with a machine, I don't think there is a real issue here. We don't publicize this at all. It's just for our internal use. We could package it and sell it to someone who's interested, but this is really not an issue. The consultants also that are in the model are really our employees or the freelancers that we work with. So we have a direct connection with these people, and that's our business. So these people, they want to be in the model because otherwise they will not get a job. Any other questions? Yeah. Yeah, we have in our ontology we define groups and we define sub nodes and synonyms. But we currently define that manually. We started off with a list of all skills that you can possibly think of within IT, and we then, when this was one big Excel, and then we went through that manually to see what are the synonyms of certain terms like service-oriented architecture and SOA, for example. That's one term. And we can then group everything as well. And that ontology is a graph in itself. So that is the core of our Neo4j graph. That's the whole skill entities, and the rest is all linked to that from that point on. Yeah. So there is no, it's not a fancy, expensive, automated way to build the skill list, unfortunately. And we also have to update it manually. That's a matter of time and money that we want to invest in it. Yeah. Other questions? Another one there and a new one. No, we don't use standards there. We just kept it simple. We could use these kind of things. These are all possible extensions, but it's just an internal thing. If we would ever productize this, then that's maybe the way to go. But
yes, yeah. Well, actually, not in Neo4j, but if you're a little bit more familiar with the plugins that you have for Neo4j, so there's something called APOC, which is the Awesome Procedures on Cycling. It's also a character in the Matrix movie, but APOC is a plugin that you can install on top of Neo4j, and there's a plugin for RDF and for OWL and semantic web type of import and export. So you actually, both are very compatible, right? So they're both graph formats, so it's quite easy to go back and forth. Actually, it fits really well one way. From OWL or from RDF to Neo4j is super easy. From Neo4j to RDF is not always possible, because we have a richer model, so we have properties on relationships, which is something that you can't easily do in an RDF model.
Any other questions? Yep. No, no, no. This tool is just built to help us, but we get this list of scores, but it could still be that number 5 on the list is a better match than number 1, because the requests are always fuzzy language. They're not always well written. We can't match everything. It's the NLP is limited that we have at the moment. So we don't try to be 100% automated. It's just that we filter out all the rubbish. That's for sure, and we can focus really on the top scores. Yeah. Yeah. We can't. No, we cannot really tell the government here that we want it in that format. No, that's why we scan documents basically. Yeah. Well, that's difficult to say. I don't have hard numbers, but we do have a few cases where we very often, if we respond with a good matched consultant before the competitors do, then you win. That's part of the business. And we have a few cases where we actually had a clear win. One of them was on a Saturday afternoon, where most people are shopping or doing something else, and it says Bing, and we could respond immediately, and that was actually a very good job. But I don't have real numbers. No. It's yeah. Still no pizza.
There is pizza.
Ah!
Go help yourself to a drink, yeah?
Hey, hey.
For the next one. And then, who are the speakers? Here? Here. You? Who's the next one? Who's the next one? I just want them. I just want her to avoid to hide behind the pillar. Otherwise, my camera cannot film. You were behind the pillar. I had to track you down, but yeah, yeah. It's the limitation of the place. Let's say. In the future, we will have cameras. Maybe cameras here. Or I don't know, but it's quite difficult to get the speaker. Wow. Hmm?
When I first came here, it was still on floor a little bit higher here, so they removed it.
Yeah, because it was not really adding a value.
Maybe those things are so. Remove those cabinets, then you have a complete floor.
But we like them because lots of meetings.
Yeah. During the day.
And since this is very open space, we need this private space so that people can have phone calls, can have meetings. So
How much does it cost to have a desk there? I'm not doing it. I'm looking for it in Amsterdam, so.
when we started, we were 800. Sorry. But the reality of the entrepreneurship in Brussels is that people need a place to work, and they can pay basic fees, but asking them beyond 200, 300, we know that they just can't do it, and then they have to leave.
Yeah.
So we prefer them to stay and to grow and find other ways to exchange values than become just another co-working space, which is there is a lot already. So we are focusing here on events, on startups, crafting links between them and services between them, and then yeah, in the future the first floor is going to be empty, and it's going to be like a exposition space for companies. So even if you organize an event here, then you can rent the space upstairs and put, for example, all of that like companies, and then people from the event can go up, make the rounds, and you don't make them do fifth floor. So we are focusing more. We are getting away from co-working, even if the co-working space here on the first floor is free for everyone. But the fixed desk and the flex desk and all this, co-working stuff. So we prefer to have people than having this empty and with people with friction, too much friction to pay for them. But there is lots of stuff in Amsterdam.
Yeah, so I'm just exploring it. I can always come home. My wife says, can you also work some days outside?
So you're the last speaker? So between this one and this one, you're free to, just don't stay here. Yes, here is perfect. Look at the camera, you see? The camera is there, so just don't stay too much time here. In the future, I will put like a red cross, so that a safe place. This is a safe place. This one too. delete it, but then it's make everything longer.
also record the voice?
No, only when you send voice through here. So we are not being recorded. That's the question. I could put some music in the background.
That's true.
So this is very easy. This on the right side, not in front of your. And this is the thing. This is the clicker. Yeah. Okay. Let's go. So you just have to put this there, and then. That's kind of
I
strange.
will use this.
Wait. Can I?
No, but it's
All right. Yeah, that's.
yeah, that's I think for Mac. I have mine. It should be fine.
All right.
So I connect.
So this is okay, like this. This goes like this. Normally it should simply wake up in a few seconds. All right, there we go. And then the clicker is okay. Because it's already it's not clicking, it's not stable. So without what? Okay. Make sure that it's on.
Hello, hello, hello. Let's go, let's go. We're going to get started again if that's okay. All right. Hello. All right. First of all, I'm sorry about the pizza shortage. I didn't order enough pizzas. I hope you're okay. You will survive. I have some reserve, but I don't know about you guys. Um, so I have a request to make because we've been beaten up by our cameraman over there, who's basically been saying that we're always hiding behind this pillar, and that we should stop doing that. So every time you see the speakers standing behind the pillar, just shout or just make a signal. You know, you're going to help, right? Yeah. So we should just try to help, because if you're a speaker, you want to be close to the audience. You're always walking around, and it's you're tempted to stand in the middle, right? So let's help our speakers. And the first speaker is Surya. Surya is going to talk to us about a super interesting topic, which is protein interactions, right?
Associations.
Associations. Okay. So I'll pass it on to you.
Thank you. Is it good? Is it good? I know my spot. Okay, so I'm going to show you a use case about protein association that I have worked during my PhD. It's not gonna be, first I'm gonna go in detail about proteins and stuff, so bear with me if you don't understand. So, okay, I'm gonna talk about proteins, as you can see. But first, let's talk about celebrities. When two celebrities are seen together in multiple events, they make headlines. Headlines, something, is there something going on between them? Are they dating? Is this just a rumor? Similarly for us, when proteins are seen together in multiple experiments, they make headlines, but in research articles, and we really get excited about them. And then you must be wondering, why proteins? Why we are so interested about proteins? Proteins plays a lot of roles in our body. For example, keratin plays an important role in as your hairs to make it smooth, your skin, your nails, and to make your muscles. You have structural proteins. So now you know the proteins are really important, but they do not work alone. They work together, like we do together. You pass a signal from one side to another side of the body or in the cell. So they have to work together to send a signal, for example, from outside of the outside of the cell. So these pink circles are outside of the cell. Just assume, use your creations, you know. It's outside of the cell, and the signal is transferred inside, so that something can be done for it. But if anything happens to one or the other protein, if they are mutated, or there is a problem with the signal, you have diseases. That's how the disease happens. You can have cancer, obesity. This is an example of mTOR pathway. That's why it's important to study proteins, but not just proteins. The proteins they are talking to, and at what position they are talking to each other. What are the functions that they are playing to talk to each other? So for that, that's where the protein association studies come into play. Protein associations are not just direct physical interactions of two proteins, but also the influence of a protein with another, okay? But coming back to my celebrities again, I told you that two celebrities are seen together in multiple events and they make headlines. But why they make headlines? They make headlines because they keep coming, they keep seen together in one event, to another, even though you don't expect them. You expect them in the Oscars, but not in a restaurant, right? So that goes same with our approach. We thought, like people who are studying or looking, these people make headlines and saying there is a rumor that they are dating or not. can we do same with the proteins? If two proteins are seen together in multiple experiments, irrespective of the fact that the experiments are designed to see them, can I say that there is something fishy between these proteins? They are biologically related? That was the idea of my project. So what I did, there are databases where scientists do their experiment and they store their raw data. So the idea was to use all the data, the raw data, use the information about the proteins and to see if the proteins are occurring in multiple experiments together, okay? And to build a biological relation between them so that we can track down using the experimental information which is stored, and we can reuse that data to say that there is something between these two proteins. So how I did that, briefly, I'm not gonna go in detail. So how we did that, we have a database, the Pride database. We took all the data, but we reprocess it. So people can submit the raw data and they can submit the analyzed data. But we decided to reprocess it by using our own pipeline. So it reprocessed the mass spectrum. It's a mass spectrometry data. I don't know if you know about it. So the mass spectrometry is a technique to detect the quantity of a proteins in a sample. So you have a sample, you run the sample in the mass spectrometry, it tells you at the end that what proteins were present in the sample. So in this process, when we do the reprocessing, we will know which proteins were in the sample, right? Then I used a similarity metric to detect a score between two proteins, because now I want to see if two proteins are seen together. How I will know it? I will know it only if I can give them a score that, okay, they were together in 100 experiments, in 200 experiments, and what were their strength of presence. At this point, I have proteins with their score. All the proteins are paired. Then there are databases which already tells you that two proteins have some association. They are involved in diseases, they are in a pathway, they are interacting with each other. They are already databases which gives you these annotations. There are a lot of them. So what I did, I have the network with the scoring. I used that database to annotate my existing network. At the end, I have these associated protein pairs. So I had this huge network. And when we talk about protein association, the basic way of representing them is this, a network. So then I used the data from the annotated. I did find a lot of protein pairs which has some biological relations which are proved by their different experiments. Now the thing is that I did the analysis. I had a huge network. I have a lot of annotations which is spread across different databases. The idea was to put them together in a database. Now when I thought of this, I was like, okay, I can use MySQL because I already built my previous project about the MySQL, but I was not quite interested in that. But good luck to me. I went to one of the talk of Neo4j and I was like, voila, this is the natural way to present the data. This is like a most natural way to tell that two proteins can be stored exactly the way we see them. So we always picture a protein like two balls and there is a line between them. And this is like a more natural way to do this. So I was like, let's go with it. So I decided that I'm gonna store in the graph database. The best thing is that you can store the proteins, which is, for example, blue in color. And annotations can be stored as well together with the associations. So green, for example, the pathways they are together, or diseases which are pink in color. So this problem solved by using the Neo4j. I use the Neo4j as a graph database to store all my data, which includes association and the annotations. So at this point, I had the schema something like this, where I can store the proteins, which is here in orange, and all the annotations which are surrounded it. But why I chose this at this point is that because when you talk about MySQL, the problem with the MySQL is first you need to define a schema. There's no problem in this. Of course, here as well, you need to think of it, what should be connected, because you need to make query out of it. But the main problem with the MySQL is that the moment you have to join a lot of tables, you make join statements, it gets too costly to get the data back. Here, it's amazing. The moment you enter in the data, everything which is connected, it's very cheap to get the data back from the database. So it works perfect for the highly connected data sets. So I was like, this is one of the way that's perfect. The second, like I mentioned about the schema, I cannot guarantee that I can stay with the same schema because we look for the association, but there are more possible associations that are possible. So I might add, for example, disease associations, the protein which localize in a particular cellular compartment, or it's specific to the tissues. So the schema will outgrow again and again. So I cannot use SQL at that point. So that's why I decided to use Graph database, which really helps me to outgrow the schema, and I keep changing, and I just love the way when I think of the graph, because it's so natural that you can keep adding a node, and you don't have to think of a query that you have to check the null statement all the time in the relational database. You have to always check, okay, it should not be null so that it doesn't give you error. But here, it's amazing. So again, when I stored the data in the database, the first thing that it helps me to get the information about the two proteins which are associating. So I've entered all the data. So I can get information. The blue line, the edge represents between blue circles are the association if they are found to be associating in my query. But the other thing which is really interesting for me is that I can search for pathways which has proteins. So pathway is green in color, which has all the proteins which are found in the particular pathway, but they are also associating. So they have a blue line among themselves, and it's so fast to query them. So I don't have to just think of association, but I can think other way around as well. I can think that I have a pathway or a disease or a tissue. Can I get information from them to the association that I'm interested to? Same goes with the diseases. Some people have some specific disease that they are studying into, cancer, and detailed information about it, and they want to know more about, they don't know which more proteins be present in the particular disease, so they can now query if, if they have a disease, they can query